All right, in this last and final part, we will be reviewing this idea of function transformations. This is just a made-up function, one I drew of straight line segments defined from -6 to +6 on the x-axis, from -2 to +3 on the y-axis. Your range would be from -2 to +3. Your domain would be from -6 to +6. I've been able to shrink this picture and put it next to all the transformations that we're graphing. So, the first one here, this should be cakewalk. Granted, not the best scale, so I'm actually going to cheat a little bit to make my life easier, and I'm going to put the y-axis right here. I need to do that because I need more room. So if this is the y-axis, I would go over, well, silly me, I put it in the wrong area, so let me clean this up. So if this is the y-axis, right there, my new HK would be back 5, 1, 2, 3, 4, 5, and down 2, 1, 2, right there. I treat this like 0, 0, okay? The real 0, 0 is right here, but I'm treating this like 0, 0. So for the graph, I would go, I'm working left to right here. I would go back 6, 1, 2, 3, 4, 5, 6, and up 0. I would go back 5 and down 2. I would go back 3 and up 0. I would go over 0 and up 3. I would go over to the right 3 and up 3. I would go over 6 and up 0. And this is the exact same shape as the original function. It just has been transformed. Notice that the real 0, 0 is right here. So this is a value of -11, -2. And this is a value of -10, -10, -4. And this is a value of -5, 1. And this is a value of 1, -2. And I hope what you see is the domain is no longer -6 to +6. It's -11 to +1. The range is no longer -2 to +3. The range is -4 to +1 because there's been a transformation. For the next function, we've got two things going on. Next transformation. We've got a 1/2 value, which will shrink all the y values by a factor of 2. They'll be multiplied by half. So all those y values will be multiplied by half. But we also have this negative inside here, which is going to flip the graph. So luckily 0, 0 stays the same. If I was going to graph this function, I would go over 6 and up 0. But now, because of the negative, I'm going to go back 6. And then I'm going to take that 0 and I'm going to multiply by 1/2, which is 0. I would go over 3 and up 3. But now, because of the negative, I'm going to go back 3. But I'm not going to go up 3 because 3 times 1/2 is 3/2. I would go over 0, but the opposite of 0 is still 0. And I wouldn't go up 3, I would go up 3/2. I would go back 3 and up 0, but this time I'm going to go to the right 3 and up 0. 0 times 1/2 is 0. I would go over 5 in the negative direction, but the negative in here flips that over here. And instead of going down 2, I go down 1. And then instead of going back 6 and up 0, I go to the right 6 and up 0. I hope you can see the general shape of the function has been flipped across the line. Oh, I'm so close. Flipped across the line, x equals 0. That's what this negative does. Do you see the flip here? Something like that. And can I do it on here? Then it would go down to here and up. Right? Maybe I didn't go down far enough. I don't know. But looks a little off. So there's that flip, but then there's the vertical shrink from the 1/2. The third transformation, a little bit more complicated. Take care of h first. There is no h. Take care of k, +1, so everything is moved up 1. This is like a new xy axis. This is the new origin. The 3 does the reverse inside to x. So if it was a 3 out here, we'd multiply the y's by 3. But when it's a 3 in here, we divide the x's by 3. So all those x coordinates get divided by 3. And then the negative out here flips them down. So instead of going over to the right 6, I go over to the right 3 and 0. Half of 6, sorry, I did that wrong. Not half, excuse me. A third of 6. So 1/3 of 6, that should be a 2. So let me clean this up with a different color. I should go over 2 and 0. Good. Now I do a third of 3, which is 1. But instead of going up 3, I go down 3. Down because of the negative. -3 times -1. Down. 0 divided by 3 is still 0. But then the y-coordinate of 3 goes down here. This x-coordinate of -3 divided by 3 gives me -1. And 0 times a negative is still 0. The -5 is harder because you take -5 and you divide by 3 and you get -5/3, which is somewhere in here. And so I would then take the y-coordinate of -2, multiply by -1, get +2. That's right here. Then I take the -6, divide by 3, get -2, and the value of 0, and that's right here. So what you need to see in this graph is the y-coordinates have been flipped, positive and negative, and the x values have been shrunk by a factor of 3. Okay, I actually think this is the easiest one, or one of the easier ones, but I think they're all kind of easy. So what the absolute value inside here does is it makes the function think every single number you're plugging in is positive. So when I plug in a +6, it thinks it's a +6. When I plug in a +5, it thinks it's a +5. +4, when I plug in a +3, it thinks it's a +3. When I plug in a 0, it thinks it's a 0. The right-hand side of the graph does not change because the absolute value of a positive number is a positive number. Here's where it gets a little tricky. If I plug in a -6, the first thing that happens is it becomes a +6. So even though the point right here is -6, I'm taking f of +6, which is 0. When I plug in a -3, the graph thinks it's a +3. And so it thinks this point should be graphed. F of +3 is 3. And I end up getting this shape that looks like a mirror image of the positive x-axis. Flipped over the line, y equals x. Sorry, not y equals x. X equals 0, the y-axis. This graph here flipped over because as far as this function is concerned, the only thing you're plugging in will be positive numbers, even if it's a negative number. All right. We're going to go ahead and jump right into the next one. No reset. This one a little different. F of x inside x isn't changing here. No matter what you plug in for x here, it's still the same value in the function. And so we take the absolute value of the y-coordinates this time. If you look at this graph, almost all the coordinates from -3, 0, all the way up to 0, 3, over to 3, 3, over to 6, 0, those are all positive. So the absolute value of a positive number is just that positive number. Where it gets a little tricky is this little negative section here. This is going to be flipped up. So here's negative 6. Instead of going down to here, it's going to go up to here. And these negative values here are going to get flipped right there. So I'll try to put the original function in blue. And I'll outline the negative values of the original function. Those were negative and these values were negative. Those values were flipped up over the line y equals 0, or the x-axis, because those are negative y values and here they are as positive. If you have any other questions about any of the worksheet, you need to raise your hand and talk to me.